Question 42 is asking us to determine a function that can model this data. So a group of students perform an experiment. They're putting mass on a spring and seeing how much it stretches. Okay, so what type of function? I went ahead and already did the math on the side. If it was exponential, it'd be a multiplication repeatedly. If it's linear, it's repeated addition. And then we just talked about quadratic on the previous, where it's that second differences. So this guy clearly is going up by 2 on the left and up by 6 on the right. So this guy is going to be linear because he's constant rate of change. Write a function that models the situation. So this one you can actually occur, like you can do it really easily. If this pattern is going up by 2, actually if I was to go back up, I know it's a 0. And if I'm going to go back up by 6, I know it's a 0. Also, if there's no weight on the spring, it should have 0 stretch. Technically, you could go ahead and do, let's go ahead and find the slope first. So change in y over change in x. So 6 divided by 2. So my slope equals 3. If you wanted to, you could actually go ahead and go straight through that y minus y1 equals slope x minus x1. So I'm going to get y minus 6 equals 3x minus 6. Add the 6 over, you get y equals 3x, which you could have known either way by going up and projecting those zeros, also knowing that adding no weight makes the spring stretch 0, etc., etc. But anyway, y equals 3x is that graph. How many grams of weight did they add if the spring stretched 78 centimeters? That is going to be my y value. So x is how much mass they added and y is how much centimeters it stretched. So I'm just going to plug in 78 for y. So 78 equals 3x. Divide by 3 on both sides and you get x equals 26 grams. Alright, the next question says the amount of medication in a patient's blood, blah, 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 gives you this equation. Identify the initial amount of medication. Initial amount is just that value there. So 100 grams. B says determine the rate of change for the amount of medicine per hour. Well, I know it's going to be a decrease because it's less than 1. So just subtract 1 minus 0.984. That's going to give you 0.016. That's the difference. That's how much it's subtracting. But I want the percent, so just move this over 2 place values, so 1.6%. Question 44 says write the function if it's translated 3 units right and reflected over the axis. Okay, so 3 units right, and then I'm going to reflect this guy over the axis. So I'm going to have to put a negative sign on there. That's an arrow there. Okay, so what's already happening to this graph is it's actually already been translated right 4 units. So I think it's easier to think about if it's already right 4 and I'm going right 3 more, I'm going to be right 7. But mathematically speaking, reflected over the x-axis makes it a negative, and then you'd say x minus 4, and right 3 means minus 3. But we know that means it's going to be right 7 units. So you could probably skip straight to this answer. You can do that math there as well. Okay, 45 gives the equation y equals x squared. She wants to translate 5 units right and 2 units down. So whenever you are moving things left and right, you're going to put it on the inside. It's going to behave opposite. So 5 units right is going to be x minus 5. And then 2 units down will behave how it looks. So it'll be minus 2 on the outside. Okay, this one says, look at the graph. What is the value of k? If you look right here, it says f of x plus k. So it's telling me that it wants to know how much this graph moved up. So here's my original graph. Here's my new graph. I went up 1, 2, 3. So k equals 3. This one, you just need to change the graph according to these transformations. This is moving right 2 units, and this is moving up 3 units. So when you do the math, just take each dot and go right 2, up 1, 2, 3, put a dot. Right 2, up 1, 2, 3, put a dot. Right 2, up 1, 2, 3, put a dot. And right 2, up 1, 2, 3, put a dot. And then boom, biddy, boom, boom, and you're done. To solve each system by graphing, you need to graph each line separately. So I'm going to go ahead and graph y equals x squared minus 4. This is actually already in vertex form. We know that vertex form is ax minus h squared plus k. There's nothing stuck on the inside with the x squared and that minus 4 on the outside. So my vertex is going to be 0, negative 4. So I'm going to go put a dot at 1, 2, 3, 0, negative 4. And you should know that every quadratic follows a 1, 3, 5 pattern unless it changes, and it changes by the value of a. There's nothing out front, so this guy is going to follow that 1, 3, 5 pattern. So up 1 over 1, up 1, 2, 3, and up 1, 2, 3, 4, 5. Okay, make sure I'm lined up there. On these guys, make sure you graph your dots pretty big because you're going to be trying to intersect these guys. Okay, terribly graphed, but there it is. Okay, the other graph is just linear, and put a dot at -2, and the slope is -1. So down 1 over 1, down 1 over 1, down 1 over 1, and go the other direction as well. As many points as you need to get a straight line, do the best you can. And where these guys intersect is my answer. So these guys intersect at -2, 0, and 1, -3. Alright, question B. This one has an exponential and it has a quadratic. I went ahead and just made the table already, but you just plug in the values. So I always want to do at least 0 and 1 just to see where those guys are. So I just chose -2 through 3. Anyway, so I just plugged in -2. You can use your calculator, so plug in -2 plus 1, you get 1.125, etc. So I'm going to go ahead and graph these dots. So -2, 1.25, -1, 1.5, 0, 2, 1, 3, 2, 5, and 3, 9 is somewhere up here. 1, 2, 3, 4, 5, 6, 7, 8. Oh, just right there. Okay, also this has an asymptote at 1, so I know it's going to have a line that never crosses at that y equals 1 line. So this is how it roughly looks. And that's the exponential guy. I'm going to go ahead and graph my quadratic. My vertex is +2, +1. So I'm going to go ahead and put a dot at +2, +1. And it's negative, and there's no other number. So it normally follows that 1, 3, 5 pattern, but I'm going to multiply by -1, this is my a value. I'm going to get a -1, -3, and a -5. So from this dot, go down 1 over 1, go down 1, 2, 3 over 1, and go down 5 over 1. So it's going to give me this line right here, my quadratic, and I can see that these guys do not intersect. If you want to check this, you could plug it on your calculator. But this guy is going to be no solution. So if they don't cross ever, then it's no solution. When solving these systems algebraically, especially nonlinear systems, you want to set them equal to each other. So I'm going to say x squared plus x minus 1 equals -2x plus 3. This is a quadratic, so I want to get it equal to 0 so I can solve whatever method I want to. So moving that, I'm going to add that 2x over, and I'm going to minus that 3, so add 2x, I'm going to minus 3. Sorry, my handwriting's terrible. I'm going to get x squared plus 3x minus 4 equals 0. And then from here, you can do whatever you want. If you would like to factor, quadratic, whatever you can, but this is an easy x method. What multiplies to be -4, but adds to be 3. Well, that's going to be a 4 and a 1. What kind of 4? What kind of 1? It's going to be a negative. So I'm going to get 0 equals, well, equals 0, doesn't matter, x plus 4 and x minus 1. Set those guys equal to 0. I'm going to get x equals -4 and x equals +1. But that's only part of my answer. So now my answer is going to be -4 comma something and 1 comma something. So I've got to figure out what that second part is. So I'm just going to take -4 and I'm going to plug it into whichever equation. So I'm going to plug it into the second one so it's a little easier. So I plugged in -2 times -4 plus 3. I get y equals 8 plus 3. I get y equals 11. So that first order pair is -4 comma 11. Second one, plugging in x equals 1, I'm going to get y equals -2 times 1 plus 3. Y equals -2 plus 3. Therefore, y equals 1. Go ahead and plug that guy in, and I'm done. -4, 11, and 1, 1 are my solutions. You could also, you just show your work algebraically, but you could also graph these two equations and then do your second trace intersect feature and double check those answers. Alright, this guy behaves the exact same way. I already made a mistake, so I just covered it up. So anyway, starting from scratch, set these guys equal to each other, so you get negative x squared plus 9 equals x squared plus 1. I want to get it equal to 0. Well, actually, in this case, I only have x squareds and numbers. So if I move this x squared over, I'm going to get a 2x squared. And if I move that 1 over, I'm going to get an 8. So it's already set up very nicely to do the square root method, which is what I'm going to do. I'm going to go ahead and divide by 2 on both sides. That way, I have just x squared left alone. So I'm going to get 4 equals x squared. Square root both sides. I'm going to get positive negative 2 equals x, which means I have half my answers. So one answer is 2 comma something, and one answer is negative 2 comma something. To figure out those comma somethings, just take positive 2 and negative 2 and plug it back into either equation. I'm just going to plug it into the x squared plus 1. So I'm going to do y equals 2 squared plus 1. So y equals 5. And I'm going to do y equals negative 2 squared plus 1, which is going to give you the exact same answer, because negative 2 squared and positive 2 squared are both 4, plus 1 is also 5. So that one is 2, 5, and negative 2, 5. Consider the graph of the functions shown for which value or values of x is f of x equal to g of x. Just look where they cross. Boom, there it is, and boom, there it is. I only care about the x value, though. So that is negative 2, so x equals negative 2, and, over here, sorry, and that is, boom, 2, so that's it. I only care about where they cross, so it crosses twice, and I'm done.